Welcome back to my channel. I hope you're all doing well and you and your folks are happy and healthy. I know it's been a while. I have been busy with my personal and professional life, and I was also busy coming up with something new like an app. And but for my YouTube channel, I thought that it would be better if I put together a running log of what app I'm building, rather than doing a big reveal once I finish all of it. I think it'll keep me on my toes, and also I hope it'll be interesting for others as well. So, with that in mind, I'm changing the format of the videos slightly for this series, but hopefully, you will find all of this very interesting and instructive. So, what I have been doing for the past few months was I was building something like a web based studio app, like a Power App Studio, which you can use to build and run tiny bite-sized workflows within your IoT device, like a Raspberry Pi, for example. I have to be honest, it's been quite a challenge, but I'm planning to persist because I think it's going to help a lot of people build interesting things with their IoT devices. To explain myself a bit, and also as to how I came to the conclusion that this would be a good idea, uh, I'm going to walk you through my research and internet searching that I did before I started building the app. So let's go. In the first instance, I looked at a reference implementation of an IoT app just to see what people do with their devices. I asked myself, what is the biggest barrier for power platformers like us in getting ourselves into the business and the hobby of IoT and physical computing? Now, the devices are pretty affordable and cheap, so that probably is not the reason. There are lots of examples of experiments in the wild in the internet, so which we can use, which means that there is no problem with finding help on building our circuits either. So what stops us and others like us from doing it more? With that question in mind, I started looking at reference implementations and saw something quite depressing. Every single experiment requires us to write a lot of code, and we are not talking simple code either. If you look at this example, you can see the amount of code we need to write for a simple implementation completed, even with the help of some brilliant Azure services like IoT Hub, Azure Functions, Logic Apps, and with our very own Power Automate. We still need to write code all over the place, and that is quite a lot to simply make an LED light blink or to switch on a little fan. The biggest barrier, I think, is the code we need to write for the device itself. Now, if we were to look at the type of code we need to write, you will see an even more depressing statistic. The most popular and the most supported coding languages are C and C++ or Python or C Sharp. Now, that is pretty tall barrier of entry for us low coders. I'm sure you agree. So I decided I needed to change this slightly. So in the middle of making the next video in the physical computing series, I decided I'm going to change tack. If I could take the complexity of coding from the device itself, things could be easier for low coders and citizen devs to safely and confidently do their experiments. So the simplest way to achieve this, according to my thoughts, is to allow low code devs to use their favorite language, which is PowerFx formulas, to program the device. Ambitious? Yes. Doable? Well, maybe. So, with that in mind, I have started on this ambitious journey of developing something called PyFlows. In a nutshell, its goal is to simplify programming your IoT device, in this case, a Raspberry Pi, using low code language, which we are all familiar with, which is PowerFX. So, what I'm going to do in the next few minutes is to introduce you to the app that I have already built, and I'm going to show you where I think it's going to help as make it easier for us to write code for our IoT devices. So let's go. So this is how um, the app looks like when it's running. And I've called it PyFlow Studio, and Berry is the name that I've given to the tool set, of which PyFlow Studio is one of them. You've got a few buttons here and there. One of the first things that you will notice is the fact that there is a connection here to a Raspberry Pi, which is switched on and it's inside my network. I've called it study, and that's why it's displayed as study, and the IP address with which it's connected to that. Now, bear in mind that you are able to run when I release this, you're able to run this app within your computer, within your network, which doesn't need to be within Raspberry Pi itself. The Raspberry Pi can be in your network somewhere else, and the system is able to, or the app is able to connect to your Pi and do do GPIO pin manipulation and all that kind of stuff without the app needing to run inside a Raspberry Pi. You'd see the interface is very simple. You've got a left pane with some options. You've got a right pane with some with it look what it looks like is a place where an editor will come up. At the moment, there is no that we have not created or selected a flow. That is why we get an empty message. We've got a few buttons at the top. There might be more buttons in the future, but for now, for this particular video, we will focus on the variables button and the first type of flow that you can create, which is on-start workflow. Now, the on-start workflow is something that um, allows you to define an initialization flow. Now, if you in the context of PyFlow Studio, a flow is um, simply one piece of formula that can be run with a trigger that we set. Now in this case, the trigger is when the app starts up in the PC. So when the app starts up, if you would like to run some flows, for example, if you want to initialize some variables, or if you want to switch on certain let's say a circuit with a few LED lights, you want to switch on one or two LED lights, you can use the onStart to do that. Now, this is the first flow support that I have added to the PyFlow Studio. I will be adding a few more, and one of them is called schedule flow, which is something where you want the formula to run at a scheduled intervals. Edge level change flow, which is quite useful when you are waiting for events to happen at a circuit level, at the at the electronic component level, and you want to respond to those events that are happening within the system. We'll cover that in a future video, but for now, I would like to show you how it's gonna look like. Now, you got your formula here. So suppose you just want to set a variable, right? So you would basically start with set var I don't know, green pin. I've connected it to pin 7 in Raspberry Pi, and I'm going to set that in. But you can see that it doesn't like the fact that you have said we're green pin. Now, this is slightly different from the usual Power Apps Studio implementation. If you remember, in Power Apps Studio, you use a set variable, and a value. It immediately makes the variable available for across the app. That's not how it's going to work in PyFlow Studio. You'll need to define those variables, right? So let's do that. Let's try doing that now. So let me go into variables, and you in this view, you are able to create a new variable, and I'm going to call it again green pin. And I'm at the moment it will support text, boolean, or number. I'm looking for number because it's a pin number, so I'm going to assign it 7. And I go, yeah, that's good. Now if I take the variable out, and I'm basically going to do the same thing again, set var green pin, and you can immediately see that the green pin is available. Now I can use it in other places. For example, I can basically use read pin var green pin equal to 0, right pin for green pin 1, else right pin for green pin 0. Now, it's a very simple formula, as you can see. But what you can do, though, is you can do some interesting things here. You can actually add comments, store or toggle green LED light, and add more comments if you want. Disable or switch off the red LED light. If and I could basically go right pin for red pin. Obviously, you don't. You see, you can see that you don't have red pin here, right? Now, one of the things that it allows you to do is you can save this every time you once you finish your formula editing. I can basically take that off and I can save the formula in here. And then now it's saved, so which means that you can now come back to it and whenever you want. Now the great thing about this, again, I'll show you how it looks like when you create a new schedule flow. Obviously, I'm still building up the list of flows that we support, but you can see that you can create more and more types of flows in the system. So that is the initial sort of things that I've created. I'm going to be expanding on it, and I would like to run you all through the building process, as in every time I complete a new feature, or maybe even weekly, I would like to just open a call up, open a video up, and explain what we are doing with PowerFx Studio and what all new features did I find, or how am I implementing it. Bear in mind that the kind of technologies that I've used here, I've used .NET 7, I've used React, I have used PowerFx, the open source PowerFx library that Microsoft has released. There is also a React component that interacts with the open source library. Then there is Fluent UI. As you can see, the UI looks very, very close to how UI typically looks within Microsoft apps. I've used quite a few other interesting pieces of technology, and I probably will be adding more and more technology that I'll be using in the near future. So keep an eye out or keep an ear out for the videos that are gonna come out. Right. So that's it for this video. I'll see you next time. Cheers.